So hello everyone, in this video we'll be solving another LeetCode problem, and the problem name is smallest subtree with all the deepest nodes. So given the root of a binary tree, the depth of each and every node is the shortest distance to the root. Now we need to return the smallest subtree such that it contains all the deepest nodes in the original tree. A node is called the deepest if it has the largest depth possible among any node in the entire tree. The subtree of the node is a tree consisting of that node plus the set of descendants of that node. Now what the question is saying that you need to find the subtree, whatever subtree, and that subtree should contain all the deepest nodes that are possible in a binary tree, like the given binary tree. So let us understand with the help of this example one. So in this example one, first we need to find like what is the deepest node possible. So these can't be the deepest node possible because there is lot more to go inside its left and right part. This one can also be not the deepest node because there is something to cover in its left part and the right part. This can be the deepest node, but if and only if some other node doesn't have more levels to it. So this can be the deepest node and this cannot be the deepest node. Same with this can be the deepest node, this cannot be the deepest node. It depends if some other elements has some more level to it or not. Now again, this cannot, or like this can be again the deepest node only if and only if some other node doesn't have more levels to it. Now here comes the main part. Now this node has the left part and the right part. Now we will check, okay, this node can be again be the deepest node possible if and only if some other node doesn't have more levels to it. So yes, but for now we will be considering this node as the deepest node. Same case with this and this. Until and unless we did not discover 7 and 4, we can say that okay, 0, 8 and 6 are the deepest node. But when we find 7, we say that okay, we got some more deep nodes here. So now we will say that okay, these 7 and 4 are the deepest nodes possible in the entire binary tree. And since we have traversed the entire binary tree, and since 4 and 7 doesn't have any of its children, so we can say that okay, 7 and 4 are the deepest nodes possible. Now we need to return the subtree which contains all the deepest nodes. Now this indirectly says that find the lowest common ancestor which contains all the deepest nodes. So its lowest common ancestor is nothing but 2, which contains all the deepest nodes. Now if there was only one deepest node, let's say 7, then we would have written only that particular one node 7 as the subtree because there is no other deepest node. So if there is only one deepest node, we would be returning only one node as our subtree. Similarly, if there was 4 only the deepest node, then we would have been returning 4 as our subtree because there is no other node to cover, so we can just return that node itself. So that particular deepest node would be the subtree itself. But since we have more than one deepest node, so we need to find what is common node in both of these deepest node. So we go up. So we say that okay, whatever height we have, let's say x is my height and x is my height, because these are on the same level, so these both of them will have the same height. Now we come at 2, we can say that okay, the maximum height that we have is x, and my left part and right part both have the height x. So we can say that okay, this 2 is the common ancestor of this node, so we will be returning 2. So you can see that okay, 5 is also containing this 7 and 4, 3 is also containing this 7 and 4 in its like children part, but we return to 2 because this is the most lowest ancestor to it. Why we are returning the lowest common ancestor? Because we need to return the smallest subtree as possible. So when we can find the smallest subtree as possible, when we can say that a particular node has its left and right child having the same height, and that height should be equal to the height of the deepest level. So we just need to find the height of each and every node, and we can just compare with this condition. Like let me just write down here. Yes. So the problem becomes very simple. Just find height or level at each and every node. Just find height or level at each and every node, and just check whether at particular node its left and its right have the deepest level possible. Now if nodes left has the height equal to deepest level and nodes right is also having the deepest level possible, that means this node is the common node to both of this what you can say deepest level nodes. So this is the only node which contains both of the deepest level nodes, so we will be returning this particular node and this will be the subtree that we can get. Now what will happen, there would be some more levels. Will we return 2, will we return 8, what we will return? We will see all the scenarios with the help of examples only. So let us understand with the help of example how we'll be solving this particular problem. But I hope you get the intuition how we are doing it. We are just calculating height at each and every level and we are keeping the variable deepest level possible. That deepest level would be nothing but the compared with the at max deepest level that we have right now and with the current level. So if the current level is greater than deepest level, so we got the new deepest level. And then how will we get returning the subtree? We will be returning a subtree if its left part and right part both contains the nodes which has the deepest level, because then only we can say that okay, this is the lowest common ancestor, right? So this is how we will be doing. So let us understand with the help of this example only. So this will be the root node. So first we will go here, so its height will be 1, then we will go here, its height will be 2, then we will go here, its height will be 3. I am only explaining the part where we will be getting the answer, because we have more scenarios to check. So if I just dry run on this entire thing, it will take a lot of time. So I am just showing you the solution path only. So till now we have the height 2. Now we come here, we have the height 3. Now we come here, now it is actually height 4. So like we can return 4 also as the deepest height, but since there is no node present, it is like logically not correct to return 4, because that way we can say that we have 4 levels in our binary tree, but we can say that we can have 1 level, 2 level and only 3 level. So when we reach a point where we have null, when root is equal to null ptr rather, so if the root is reach the position where there is no node, so instead of returning level, we will be just returning level -1. So this 7 will have the level 3 from its left and right. Now this 3 will be returned to 2. So 3's left has the deepest height as 3, and then this will continue to get the deepest level from the right part also. So this will be coming out as 3. So now 2 is come to 4. So its level will become 3. Now 4 will do the same thing. It will go on to its left and right part. Similarly 7, that the way 7 did. 7 also gone to left and right part. Now 4 is also going to its left and right part. Now again we have the level 4. So we will be since the root is null here, so we will be just returning level -1. So this 4's left and right will be like what you can say 3 only. Now here when we were at 7, we can also say that this could be the lowest common ancestor possible, because here also you can say that nodes left is returning as 3 and nodes right is returning as 3. So this could be the lowest common ancestor possible, and we could have returned 7. But why we didn't return 7? Why we didn't kept our answer as 7? Because it doesn't contain all the deepest node. It contains only one deepest node, that is 7 itself. It doesn't contain 4. So why we are returning 2? Because it contains both the deepest node, that is 7 and 4. So when we return from here that we get 3, this 3 will be returned to 2. So now this 2 will say that okay, my left part contains the deepest node at level or the height 3, and my deepest node, my right part also contains the deepest node at height or level 3. So now we can say that okay, now 2 will be the lowest common ancestor. Now still this can't be the final answer. We will be checking each and every position. What if we get some nodes here also? But for now our answer will be 2. And if we did not get any more deepest nodes, or we didn't get any more nodes that are at the same level, we would be returning true. We would be returning this 2 only, because this 2 has the left part which contains the deepest node and right part which contains the deepest node. So let me show you 2 more examples which will make this problem more clear to you. So yeah, same thing here. We are starting from root, we are going to the one level down, we are going to one level down, and here we will say okay, its left and right part is 3. So we are not returning 3, we are returning actually 2 from its right and left part. So we can say that this 6 can be the lowest common ancestor to itself only, because this is the deepest node. So our deepest level is nothing but 2. Now we are at node 6. So node's left is returning as 2, node's right is returning as 2. You can see node's right has the value 3, but we return 2 because logically there is no node, so we won't return level 3, we will return level 2 only. So node's left returned me 2 and node's right returned me 2, and 2 is the deepest node also. So this 6 could be the possibly the deepest node possible, so we would be returning 6 as our answer. If and only if we don't find anything below, anything at the same level or more below to it, if then only we would be returning 6. In this case there is nothing at the same level which has the same deepest node or the same deepest level, and there is no more deep nodes to it. So in this case 6 is the deepest node. Since it is the only deepest node, we will be returning 6 in this case. So in this case we returned 6. And why we returned 2 in this case? Because in this case we had 2 deepest nodes, so we would be finding upwards to have these which would contains these all these 2 nodes. So that's why in this case instead of returning 7 or 4 separately, we return 2, because we need to contain all the deepest node, not a single or few deepest node. We need to contain all the deepest node. So to contain all the deepest node, we need to find a parent which contains all of the deepest node. So that's why in this case we return 2, and in this case we return 6 because this was the only deepest node. So if it is the only deepest node, we would be returning the node itself. So I hope you understand this part as well. Now let us see one more example where we won't be returning 2 or 0, because you see here 7 and 4 are the deepest node. So in the first example we were returning 2, but in this case we won't be returning 2 because there is one more node which contains the deepest nodes. So at the same level as of 7 and 4 we have 9 and 10, and this 2 doesn't contains the deepest nodes 9 and 10, and same way this 0 doesn't contains the deepest node 7 and 4. So we want to go more further up which contains all these 7, 4, 9 and 8. So we will say okay, is 5 the node which we can say it contains all the deepest node? So 5 contains 7 and 4 but not 9 and 10. So does 1 contains all the deepest node? So 1 contains 9 and 10 but does not contain 7 and 4. So we will go further up. So now we are at 3. So now if we are at 3, we can say that okay, 3 contains 7, 4, 9, 10. So 3 contains all the deepest nodes. So in this case we will be returning 3 as our answer. Now logically also the intuition that we had, we can apply here also. So 3, so this will return 3, this will return 3, and finally 3's left part will say okay, when we are at 3, when our node is at 3, so we can say node's left part is 3. That means this 3's left part has the deepest level which is 3, and 3's right part will also return 3, because here also these are present at level 3. So this will return 3, this will return 3, this will return 3 also. So 3's right will also return the 3 as the deepest level. And what is our actual deepest level? Our actual deepest level is 3, because all of these nodes are present at level 3 only. So we can say that 3 is the node which contains the left part as the deepest level and right part as the deepest level, because deepest level is 3. So we can see that okay, whatever this node is, we will say that we will return this node. So that's why we are returning 3, because 3 contains now all the deepest nodes. So I hope you understand the entire explanation part. So this is pretty much easy to understand problem. Just we need to calculate height and we just need to maintain the deepest level. So let me just write down here so that you can see it more clearly. So first we need to calculate the level, then we need to calculate the deepest level. So deepest level will get updated if the current level is greater than the current deepest level that we have till now. And what point we can say that we need to return the node? If the node's left part is equal to the deepest level, as well as node's right part is also equal to this deepest level. So node's right is also equal to this deepest level. Now in this case we can say that okay, this node contains all the deepest nodes that we have in the entire binary tree. So we will be returning this particular node as the starting point for our subtree. So this is how we'll be solving this particular problem. So let us see the code now. So this is the code. First of all, I have declared two global variables. One is the deepest level initialized to 0 and other is the answer initialized to null pointer. This answer will contain the node which follows both of the left and right condition that we have seen in the drawing explanation part. Now we'll be running the DFS from the root node and we'll have the current level as 0. And after the DFS, whatever node we get, we'll just return that particular node. Now in the DFS, what we are doing, so this is the base case. So when root becomes null or root reaches the null pointer, so in that case we'll be returning level -1. So why we are returning level -1? We have already discussed in the drawing explanation part. Now we are going towards the left and we are going towards the right to find the deepest node possible. So whenever we are going towards the left, we are just passing root's left pointer and we are just going level +1, because if we are going towards the left, we are going one step deeper. Similar with the right, when we are going right, we are just passing the right pointer, root's right pointer. And since right pointer is one level deeper, so we are just doing level +1. Now we are calculating the current level. So current level is calculated by maximum of right comma left. Basically how we calculate the height of any node. So let's say its left part contains 2 and its right part contains 2. So actually its height would be 2, because in the left part it can go 2 level deeper and in the right part it can go 1 level deeper. So obviously we will be taking the maximum one to calculate the height or level of it. So that's why the current level is determined by maximum of whatever there is on the left and whatever there is on the right. Now we will update our deepest level if it is possible. So it will be updated by whatever the deepest level that we have so far and with the current level that we calculated here. Now the condition where we can say that okay, this is the answer that we have. So if our left part is equal to the deepest level as well as the right part also contains the deepest level, that means we can say that this root is the answer. So we will store root as our answer for now, and then we will be returning the current level in the end. Now this answer can be this particular root. I am not saying that okay, this will be the root, this will be the answer only, because in the example we have seen, in this particular example where we have this 7, 4, 9 and 0 as the deepest node. So for when we were here at 2, we will think that okay, 2 is our answer. Again, when we were here at 0, we will think okay, 0 is our answer. But when we reach 3, when we are returning from the recursion part, when we are returning from the DFS calls, then we are realized okay, then this 2 realized okay, there were few more deepest nodes, and then this part 0 realized okay, there were few more deepest nodes. So for this, so this 2 would be saying that okay, I didn't know about these 2 nodes, and this 0 will say okay, I won't know about these 2 nodes. So that's why we return 3 here. So at this position when we are at 2, this 2 was thinking okay, I am the node which contains all the deepest nodes. Similarly, when we are here at 0, this 0 would also think that I am the node which contains all the deepest node. But when we reach from the further recursion or DFS calls, that's when we realized okay, there were few more deepest node possible. So that's why we are not returning from here anything, or we are not like just breaking this thing from here. We are just saying just store this current root as our answer, because this can be the possible node as our answer, or this may not be the possible node as our answer. When this particular node be the possible answer, if and only if the node that it contains on the left and right part are the only deepest node. And when it cannot be the answer, when it contains the deepest node, it's okay, but there is some other node also which contains the deepest node. So in this case, this particular root won't be our answer, because this root doesn't contain these two node as its deepest level. Similarly, whatever parent it would have, this will also won't be the final answer, because this node doesn't contains these two node as its child. So that's why we will get some other root as our answer, but for now we will keeping our root as our answer. So yes, in the end we are just returning the current level, and after this DFS call ends, we are just returning whatever answer we get. So I hope you understand this entire problem. So I have attached few more binary tree questions in the description, so you can watch that out too. So I hope you understand this solution. Thank you for watching.